So, just a short recap of the me remembering to start the video. We're not going to have an assignment due during exam week. We're going to skip assignment 10, do assignment 11. Assignment 11 will be due this at the end of the week, all right? In the usual fashion, but this will be the last assignment, okay? And that gives us 10 assignments that we managed to get through in total. 10's a nice, like, round number. I'm very comfortable with 10, you know. 9 would be one too few, you know. So, 6 minutes. You will create a workflow with GitHub Actions to automatically test the findthelowestnumber.py application found in this zip file. See the comments at the top of the file about how to use the program. There are the comments redone for you. New public repository, upload the file, create a workflow, test the application using diff to compare expected program output to actual program output. The automated test should run whenever a push event occurs. Use appropriate job step names and so on for other keys in the YAML file, as we do when making a workflow. You should have 3 test cases in your workflow. 1, 2, 3. So this is intentionally designed to travel quite close to the demonstration that was given in lecture. So if you recall yourselves back to that, follow that rough procedure, apply it to this problem, you'll be off to the races. Okay? Complete all the above work before creating the demo video. In the demo video, you should merely do the following. Commit to the repository, purposefully modify one of the expected output files and commit this change, and then show that the test fails using GitHub Web GUI. That should only take a minute or two, right? The below code violates one of the solid principles. Refactor the code so the principle is no longer violated. Yes, and then explain it. Yeah, I guess we will have you explain it in the video then. It's not exactly an essay. Marks will be awarded for clearly identifying how the given code violates the chosen solid principle, refactoring the code appropriately, and explaining why the refactoring improves software design. Please use accurate terminology as discussed in class. Fair enough? That doesn't seem too bad, right? Okay. Man, if they were all 6-minute videos, that'd be great. So, unfortunately, we're not going to get to pair programming, but we will cover debugging, test-driven development, and PyUnit. So, yeah, today's the last lecture. I consider this to kind of be like a fun, slightly fluffy way to cap off the semester. A lot of the stuff in here is either going to be information that you have arrived at independently, possibly, or, you know, this is kind of one of those things where, like, I know it might be like, we're going over some slightly basic stuff, but there should be some useful nuggets of information hidden here that, if applied correctly, vastly improve your ability to debug code. So, just, you know, just keep that in mind, that the goal here is substantially fewer headaches for all of you in the future, right? I'm trying to improve your life. So, debugging. everybody's favorite activity, right? So, debugging is the process of finding and fixing bugs in software and computer systems. A bug is some fault or flaw. In this class, did I show you what the first computer bug was? Yeah? Yeah. So, if I were to offer a slightly more technical definition of what a bug is, when we design software, we have requirements. Those requirements are either implicit or explicit. They're either written down or they're in your head. The written down ones are better because you can check them more easily. Implicit is bad because you could forget what those implicit requirements are, right? Basically, a bug is any time the software does something that violates its requirements, right? So if it's expected to calculate 3 and it calculates 2 instead, that's a bug. Or, if your video game character clips through the floor and falls into endless space, that's also a bug. It's functionality that was unintended and is undesirable, right? Have you guys heard the bug versus feature debate, I presume? Right? When is a bug a feature? When you decide that the unexpected functionality isn't undesirable, right? So, developers spend 35 to 50% of their time debugging. See this link? How developers spend their time. No, not but.
Can I come in?
This is a class. Yeah, are you in the class?
Yeah.
Well, then come in. You got a graph for me? No, just an article. Okay. So, I will say, on the subject of 35 to 50% of your time debugging, that's like nominal development. You also have situations where, you do your initial thing of a program in weeks to months, and then you spend basically the rest of your life debugging it. This is generally referred to as maintenance. Maintenance is not always including new features. It's often squashing bugs. So, why isn't there why is this the first formal treatment of debugging that you're getting in this program, if it's so important? Well, it's not just us. This is basically never really directly taught anywhere, right? It's kind of at the level of individual instructors a lot of the time. Like the ones that tend to go on rambling tangents, such as myself, will often go on tangents about debugging techniques, that sort of thing, included as part of the informal curriculum. But this is the course where we talk about the stuff that isn't covered formally elsewhere. So, debugging. Different techniques and tools exist to help us debug our programs. We're going to go over some of the common tools and techniques. Debugging, the scope of software problems is very broad, right? You can be debugging everything from a little tiny off by one array error all the way to massively complicated parallel execution problems, which are notoriously difficult, right? But first, let's make a distinction between the algorithm and the implementation. So, the algorithm is essentially the program as it exists in your head. The implementation is the algorithm as you encode it, right? So the algorithms in general, are a finite sequence of instructions which solve a problem, typically receiving some input to produce some output. Algorithms can be represented by multiple different types of things: flowcharts, pseudocode, and even source code itself. We create an implementation of an algorithm when we write the algorithm using source code. Some bugs are due to incorrect implementation. Some are due to an incorrect algorithm. So the point that we're trying to drive at here, sometimes the failure is your ability to produce the program you intend, or the program that's been specified. Sometimes the problem is the program itself, right? The algorithm you are trying to implement itself is wrong, right? Maybe you're using the wrong type of search algorithm or something, right? If the error is in the implementation, the implication is if you fix the implementation, you will have solved the problems. But if the algorithm itself is flawed, fixing the source code will not fix the problem. The problem is deeper than that, right? You have to rethink the algorithm and then re-implement that rethought algorithm in order to fix the problems. You know, it's going to be inevitable for me to talk about my thesis project at least a few times during this. Part of the reason it took me a good 8 or 9 years to do that software project was about every 1.5 to 2 years, I discovered massive algorithmic problems, and thus I had to take the beating heart of the software, rip it out, throw it, into the trash can while my hand really doesn't want to let go of it, and then recode that core algorithm with my now improved understanding of the problem I was trying to solve, right? So the thing that limits your ability to design the algorithm is fundamentally your understanding of the problem you're trying to solve. And good luck to you, because the problems are numerous and the solutions are few, right? It's fully understanding a problem, a software problem, can take years, right? Years of work. Lots of the advice that you get in this course is trying to avoid that type of those types of problems, but to some extent, if you're trying something sufficiently complicated, you're just not going to understand it, right? You're going to write a program that doesn't solve it because you didn't understand it in the first place. You will learn about the problem through that implementation. You'll have to scrunch it up, throw it over your shoulder, go back to the drawing board, try again with your improved understanding. Some of you may have even been through that process a couple of times in the course of school assignments, right? There's no shame in it, right? You may have put pen to paper somewhat prematurely, but, the important piece is that you get there in the end. So, regardless of any particular debugging tools or techniques that are being used, we should keep this distinction in mind. Even if we perfectly implement our algorithm, it won't matter if the algorithm itself is flawed. So, once we've confirmed that the program is working as designed, but our output is not what we expected it to be, we may need to change the design itself. Well, you basically have two options at that point. One is to go back to the drawing board and do a redesign. The other is to, lower your expectations for what the intended functionality of it was in the first place. It's kind of like, our space program, we were trying to get to the moon, but we only went to orbit. But, I think we were trying to get to orbit the whole time, right? That's kind of that approach. Print debugging. This is, how many people use this technique? Okay. So print debugging involves inserting print statements into the code to determine what is happening. Your ability to solve the bug is completely dependent on your understanding of program state, how the program state is changing as the program executes. The most direct way of inquiring after program state is to just print it, right? So, for example, we have an algorithm. When we print the output, we get an incorrect result. I'm not particularly interested in dissecting this particular algorithm, because I think everybody knows what I mean when I say put a print statement in it. Because they're tight. If we put print statements in at strategic points, and it's important that the points we put them in be strategic, we can get output tracing, right? We can trace the progress of information through the program. So if we consider, okay, you guys want spoilers? It's an off by one error that's not looking at the last item in the array. So because the last item in the array is the lowest, it misses it and it thinks 3 is the lowest item in the array, right? So the points at which we are strategically inserting, right, before the loop executes, at the top of each loop, and inside this if statement, which is a point of interest, right? I don't know how many times I have just printed something to see if execution reaches a particular branch, right? The information itself doesn't even have to be, particularly interesting. I often use a dummy character like exclamation mark, right? Another thing, if it gets sufficiently complicated, I'll do 1, 2, 3, right? And that way you can tell which branch is executing which, you're mapping to numbers, it's a little easier than counting exclamation points, but, for simple problems, exclamation points work perfectly well, right? But the point is, we're inserting this at strategic points so that when we take a look at our output, it's immediately obvious to us that 1 is never looked at, right? So, we then realize that the problem must be an off by 1 error, make a slight adjustment, and run it again. We now are looking at 1, we're getting the correct output, and we're off to the races. And of course, we now have the worst part of any print debugging, which is removing the print statements when you're finished. Although, I'm tempted today to say something like easy enough to do with a regular expression. But, everybody who knows sed now that you've done this course should be able to regular expression out the line that a print statement exists on and then delete it. It's dangerous though, yeah.
Something I saw Stephen Adams do is he put there's a function called like print debug, and then you put your string in there, and then you have like a flag at the top that says like is debug, and you can just set it to true or false, and your prints aren't done, you're not debugging anymore.
Yeah, so this is generally what's understood as a verbose mode, right? A lot of Linux programs, they have something resembling a -v flag for verbose mode, like even things like CP, and it's basically the difference between silent execution, where it doesn't say anything, and I'm going to give you more information about what I'm doing. People will even like debug at various levels, like debug level 4. It shows you like a whole, like stuff pertaining to this, but not pertaining to that, right? We're now kind of shading into the art of the log file, right? But yes, you absolutely, like debug modes are absolutely a thing. You can do them, like, there are two primary modes, right? The first mode is the one that you described, where within the language itself, we're having the language itself support the debug operations, bunch of if statements, right? Another approach, like the downside of that approach is that you're affecting runtime by doing that, right? So how do you do that without affecting runtime? Precompiler directives, right? You use the preprocessor. So in C, it's all fuzzy. Yeah, there's an example for you. Reject. There you go. So, in the C programming language, right, like include or import is technically a precompiler directive that takes the entire contents of this file and dumps it right there, right? But you also have other interesting ones like define statements, right? So anytime you see this hashtag in C, that's not a comment. That's a precompiler directive. All of these are removed from the file when as a precompiler step. So if you use, actually, you know what? I might be able to find a better. Let me refine my search. C precompiler debug mode. Yeah, this looks like it. Maybe? Yeah, there you go. There's some code for you right there. So basically, this is like a define, right? You can use these for character substitutions, but if def just checks to see if this has been defined, right? So if debug has been defined, you can put a bunch of code here, right? And this doesn't have to be more defined statements. This can be like proper first-class programming code. You can put these things inside of main, for instance. You can drop this anywhere and like basically toggle on and off a bunch of debug statements. But basically what you have to do at that point, whether or not the program is in debug mode, is based on whether this line is in the file. So you compile two versions, right? You compile the debug version of the program and the production version of the program. The production version, you simply delete or destroy this. You know, you could even write some Linux commands to get rid of that thing fairly easily as part of like a make file or something, right? And yeah, you just compile it, the debug version will have all the print statements in it, the non-debug version won't. But it will be removed at the level of the pre-compiler, so the actual compiler itself never even sees the print statements or the if conditions or anything like that in the production version. So it does not slow down, it doesn't slow down your execution speed whatsoever for the production version, though it does slow down the compiler a bit. But generally we don't care about slowing down the compiler because we only have to run the compiler once. Right? Question? Follow-up question?
You called them preprocessor directives, right?
Yeah.
Is that different than a preprocessor macro, or is it the same?
No, that's the same thing.
'Cause I always heard they were really bad to use.
Yeah, yeah, you can do some really bizarre stuff with them. Yeah, they're kind of like, to some extent, it's like kind of like go-to territory, here be dragons. But it depends on what language you're using. Like in C, this is like kind of essential. Like, you know, true and false, they're defined statements in C. And in fact, you only have access to true and false if you include the Boolean standard library. Otherwise, you're stuck using ones and zeros. So, yeah, it depends on what language you're in, but, you know, like a lot of these interpreted languages wouldn't care about that level of performance anyways, right? But if you're starting to talk performance, that's how you improve performance and still get your debug statements. Make sense? But yeah, I do agree in general that like defined statements are kind of a here be dragons kind of topic. Like even when I'm teaching a course in C programming, I don't really require the use of defined statements in like assignments and stuff. It's like you need to know what these are. Here are some slides on it, kind of material. Yeah, make sense? Any questions? Cool. C is a lot better than people think it is. Did you know that it's impossible to it's possible to write a C program that's impossible to kill? So the way that you like kill a program using Control-Shift-Escape or HTOP is HTOP is the Linux utility that does that. It's much better. It sends like a signal, the operating system signal. Normally for ending a process, it's either sigterm for terminate or sigkill, which is like the souped up stronger version. It's the less polite way of sigterm, right? A way of saying sigterminate. And what you can do in C is you can write, using the signal processing library, you can write a C program that handles the signal, right? So it sets up a handler for the signal. So it can set up a handler for sigkill that resets up the handler for sigkill. And so anytime you try to kill the stupid thing, it's like, nah, I'm not dying today. And so that's how you write a virus. Where were we? Oh yes, debugging. So, print debugging. Surprisingly powerful. This has been the instructor's go-to debugging technique for about 30 years now. Smiley face. For me, change that to a 2. Kevin's been at this a little bit longer than I have. God, I've been programming for 20 years. Because, like, I'm 37 now, and I started programming when I got my first laptop, which I bought from the proceeds of my stupid fast food job at Pizza Hut. And I started programming when I got my first laptop, and I was like 17. Yeah. So yeah, I've been programming for 20 years. and I share this sentiment. Whenever I have to debug something in class, this is the first thing I try, right? The trick is to strategically add print statements to the areas of code that are under suspicion of being incorrect, outputting values of interest. Like all debugging techniques, the more specific an idea you have of where the problem is, the faster you'll be able to find it, right? But you can also use techniques like binary search. You guys know binary search? You know you can like use that to find like syntax errors and stuff? Yeah, it's easy. If you're trying to isolate a syntax error, you have to be a little clever about it and not introduce more syntax errors. But if you comment out about half the code and the syntax error is gone, you know it was in that half, right? And then you can take that half, comment out about half of it. If the syntax error is there, you know it's in that half, right? The half you didn't comment. Like you can use these techniques, you know? It's kind of funny. You can use the same technique on game shows too, like guess the number game. There's a guess the number game show on The Price is Right, and it's like every once in a while there's an engineer on The Price is Right who like uses binary search to find the guess the number on the guess the number game, which is always very entertaining for me. My wife sometimes watches The Price is Right in the evening. It's nice, something fluffy to end the day with, right? And also it's really quite amazing to watch the hairdos from the 70s. Yes. Sometimes the output can give you clues as to where something could be going wrong. Sometimes we just need to use intuition and instinct. That's right, unfortunately it's one of these things where the more experience you have, the more refined your sense of where it is, the better you'll do. In the worst case scenario, we blanket our code with print statements outputting many values. This is probably where a lot of you guys are. This will make interpreting the results difficult, but we should capture the root cause of the bug somewhere in the output. So if you have to blanket the thing in print statements, make sure that those print statements are interesting and distinct, right? It does absolutely no good whatsoever to put in about 30 or 40 print statements, each one of them printing an exclamation mark. So, print debugging is a form of program tracing, where we capture and record information about the execution of a program. There are other ways that we can conduct tracing: debuggers, log messages, etc. So, what are the advantages? Print debugging is lightweight. It requires nothing except the thing that every language comes with. You have complete flexibility and control. You are always in control of the print statements, depending on the language. Personal trauma. It's a little difficult in Haskell. Having to type out print is a small cost that forces you to think about the program, what could be wrong and what to investigate next. So it's a little bit of work to put the print statements in, but that little bit of work, it turns out is very useful to solving like the problem. For example, in our previous example here, right? When we're printing these variables, we must first conduct a mental analysis. What are the important variables for me to see right now, right? What is the variable that might have the problem? Normally, you can get that pretty easily from reading the source code, but it forces you to read the source code, it forces you to understand at least a couple of things about the program before you continue, right? So, it enforces a small cost, but that's useful. It helps you understand the problem. There are computer-human interaction studies that show encouraging users to think by enforcing a small cost on each action makes the user take smarter actions. And of course, we all know this. If your approach to print debugging is to simply blanket the thing in print exclamation point, how much cost is there to print exclamation point? Almost none. It's like enter, control V, right? If you are actually polling the status of variables, you must look at the code, right? In a sense, like printing exclamation point doesn't even read, like it doesn't really require you to read the code very deeply, right? So, the big disadvantage of print debugging is that once the bug is found, all the print statements should be removed. Which brings us to logging. Large software applications will use logging, typically with the assistance of a logging library. So, what is a log? Well, a log is just a bunch of print statements that have been collected up into a big file. That is what a log is. It doesn't have to be more complicated than that, right? At certain points of interest through the program, a logging function is called along with a logging message. For example, transaction completed successfully, insufficient funds, customer being redirected, things of this nature. If you think about like servers, server logs are like an obvious application here. Like, you know, when you receive an incoming HTTP packet, maybe you record like what the IP address was that connected, right? These might be useful and important things to know if something goes wrong. If under cybersecurity protocols, if a breach is detected, one of the first things you have to do is very quickly go into the log files and see if you can isolate the attacker, right? grep is your sharpest sword in that particular defense of that particular castle. Or maybe it's an arrow. Maybe that's the wrong sort of... Well, if the breach has occurred, they're already inside the castle, so you will need a sword. So, the amount of log message output that can be configurable so that log messages have to pass a certain threshold level of interest. So basically, you could say this is a level 2 debug message, right? You can even like regionalize log messages to be about particular things, right? Like network traffic related debug log messages should be stored separately from stuff to do with like internal server stuff, or like connection to the client should be stored separately from connection to the database server, right? Logical distinctions. You also have to keep in mind that when you produce logs, you have to store them. So if you're producing it in extremely voluminous quantity, it's a question of how much are you storing and how far back are you keeping it, right? Are you keeping log files going back like 7 years? Maybe if like your service involves a lot of like financial transactions and tax receipts and stuff, those records have to be kept 7 years, right? Maybe even longer. But logging is essentially a form of print debugging. It's really only done in larger applications, and it takes time. Basically, you have to make the trade-off decision. Is it worth the memory to do this? Is this the information we could get from logs sufficiently interesting that we should keep them? And the answer to that is memory gets cheaper all the time, unless you're talking about RAM at the moment. Have you guys seen what's gone on with RAM? Were we talking about that last week? No? Someone else was talking about that last week. Oh my goodness gracious. 64 gigs of DDR5. Boom! That was like $40 a year ago. You guys know what's happened?
What happened? The centers?
Do you know what's happened?
Is it data centers?
It's actually, okay, this is what's happened, right? Friggin' OpenAI people, like, decided that they're gonna buy, like, 1/3 of all of the RAM chips on the market, all at once, and then hardware manufacturers are now like, but we need those for computers, guys. So, like, hardware manufacturers are now stockpiling at these prices because this is like half the cost of a laptop. Think about what that's going to have, the effect that's going to have on laptop prices, right? But they're stockpiling at these prices because they're like, if these stupid AI people are going to buy up literally all of the RAM, we can't actually manufacture computers. So we have to buy the RAM. And so, like, just one more way that AI is screwing up everything. But yeah, that's a problem. That's a real problem. RAM was cheap a year ago, right? And you want to know something? I think I looked at that like last week and it was 200. So maybe I'm thinking of 32. No, that's if you really want to knock your socks off though. Dun da 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 dun da 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 dun da da da. By the way, when you buy like 128 gigs of RAM, you're often buying like two 64s now. That's kind of how they're packaging it. But it's interesting, right? Because of the way that like semiconductor manufacturing works, like the supply of this stuff is actually kind of not very elastic. Like there's only so many plants that make this stuff, and it's very expensive and difficult to set up new plants to make this stuff. So like, you know, it's kind of one of those industries where like they have to plan like 4 or 5 years in advance, right? Because it takes that long to set up a plant to start pumping this stuff out. So so if you have any RAM lying around, just understand that used RAM is probably like seeing a similar uptick in resale value. So, you know, and I don't even think that that's like being like scummy and taking advantage of the market, because like it is kind of being scummy and taking advantage of the market, but like you're also making more RAM available to the market during a RAM shortage caused by frigging OpenAI. So, yeah, I don't want to buy a laptop in the future. There are some laptops on sale right now, so Black Friday. If you need a new computer, get it now. Because obviously what's going to happen is those prices are going to get passed on, right? Like, if the RAM stick is now worth half of what they were charging for the computer, that's going to have an effect on the price, right? Anyway, you see what I mean when I said this was kind of a fluffy little lecture? The tone is light, well, except for that. The world is ending. RAM is expensive, but, you know, rubber ducks, right? So, explanation of this principle. This is actually a legitimate debugging technique that you may not have heard of. So,
I've used it.
you've used it?
Yes.
Is it
not
effective?
An actual rubber ducky. I use a person instead.
Ah, yes.
That's my rubber ducky.
Ah. See, this is like your corporate version where the manager is very interested in you not wasting your colleagues' time, right? So here's the idea: rubber duck debugging, right? Have you ever noticed that you'll often come up with the solution to a problem as you're explaining the problem to someone else? Right? This is like a typical thing of human beings. It's the reason it happens is because in order to explain the problem to someone else, you have to put that problem in words. In order to put it in words, you need to understand it, right? So it forces you again to kind of think the problem through for the purposes of communication. So, if ideally, in an ideal case, you're doing this with a programmer who can give you useful feedback, right? You can probably get the same effect with the bloody chat prompt because you're having to phrase the question for the chat prompt, right? Except the chat prompt is going to give you false information, dubious information coming back, so maybe not. But it's kind of it also works with significant others who are normies, or perhaps a close sibling. People who are not programmers who are in your lives, I know I have used this technique on my wife, and bless her soul, she's very good about enduring it. But so yeah, in this sense, my wife is my rubber duck. But the idea is that if you make it like an inanimate object, you're not having to waste somebody's time by explaining a problem to them they don't care about, right? You do have to kind of pretend that it's that it's a thing that can listen to you. So something with a face is good. It doesn't have to be a rubber duck. It could be like a teddy bear or something, It's not recommended to use a pet because pets can be distracting. Yes, Professor Kevin Brown's variation on this is to write an email but not send it, basically. Because, you have to compose the problem as you're writing the email, right? And this is this is a much better version of the thing that a lot of people do, which is write the angry email and then delete it. Hopefully delete it, hopefully not send it, right? But at worst case, it's you get this long email about some problem, you're like, I don't know, man. It's oh, I didn't mean to send that to you. It's oh, okay. Also, talking to inanimate objects is if a normie sees you do it, they'll have questions, So, yeah, at least, not even just normies, but anybody who's not aware that you're using it for debugging. If you said to a programmer, it's okay, I'm trying to think through some debugging stuff. It's oh yeah, okay. But normies are less likely to accept this explanation. And just think that you're crazy. Which, perhaps you are, because you decided to become a programmer in the first place. But, so it goes. Okay, next technique. Commenting out code. This is one that I used to use quite a lot, but these days I'm not using it quite so much. Mostly because I'm not doing large projects at the moment. I'm mostly doing developing assignments for people and doing bash script automation. I still find myself doing it though. So basically, if there's a block of code that has a problem, disable it, right? Disable it. One of my favorites with this is to disable a block of code and then let the code back in like a couple of lines at a time, right? You can then pretty nicely usually isolate where it went wrong. It's a little bit like print level debugging at that point, but it's like, it gets, not quite as, it does a slightly different thing. They overlap, but they do slightly different things. Yes? This was actually, this was what I used comments for long before I used them for documentation. If we wrap code inside of a comment, it will have the effect of turning off the code so that it no longer executes. We can then run the program to see the effect of turning off this code, potentially narrowing down where the problem is. Plus, we haven't lost the original source code. We can simply uncomment it to turn it back on. Here's the problem, though. Don't use this as version control. Alright? A thing that I've often done in the past, it's like, well, here's my old version of the code. Copy, paste, make some changes. I still have my old version if I need it, right? Then, you iterate on this version quite a few times. You go back, you go on vacation, you come back, and there's just this huge chunk of source code, and you don't even know what it's for or why it's still in your code, right? And you're like, well, I should clean it up, get rid of this, I don't need it, right? I don't even know what it's for. It turns out you needed it, you didn't know what it was for, and you deleted it, and that was bad, right? Version control is intended to solve that problem, right? If things are under version control, you don't have to worry about being destructive to your existing code by modifying it, because you can always revert to a previous commit. But it does mean you have to commit, and you have to commit frequently. I always say that failure to commit is commitment to failure. So, yes, I think we can probably, yeah, fine, sure. So, error messages. Some bugs will cause incorrect output where the output is not what is expected, but some bugs will cause the program to crash. It might not be a crash in the traditional sense. It could be something more benign, like an uncaught exception. Are you guys familiar with the term soft lock? Right? This is, I think, a term that's mostly used in video games, but it describes a phenomenon in software quite well. A soft lock is where the program looks like it's running, but you're stuck in a particular state, right? For example, traditionally in a video game, right? You're soft locked if you somehow enter a bug where it's impossible to go to the next screen in a 2D game. It's you can still play inside of this area, right? You still have your character interactions. Technically, the program is still running, but you cannot proceed with the rest of the game because you've been soft locked in this in this territory, right? You can that's a thing that happens in programs generally, not just in video games, but that's the term is soft lock, and it's also a bug. It's not quite as bad as a full crash, but it comes pretty close to being as bad as just blatantly crashing. Oh man. I made the mistake of trying to play the Subnautica sequel on the Switch, and man, that thing crashes to desktop. Like, nobody's business. Like, what is, like, you released this? And it's some problem in the loading routine. Like, I isolated it, because it always occurs when you're like, it seems like you would be triggering like a load of the next area. That seems to be where it, like, I kind of, you know, because we can't play video games, right? We have, all of you will pass at a certain point beyond the ability of other people to enjoy video games. You won't be able to enjoy video games the same way that other people do. Because you'll always be like, oh, I know what's causing that, right? You don't, like, you're like Neo in the Matrix. You're not seeing the game anymore. You're just seeing the numbers, right? But yeah, anyway. And it's like, at that point, you're like, you can step into being a speedrunner. But if you're actually a speedrunner, do you even enjoy the game you're playing anymore? You know? It's an open question. Maybe, maybe not. Anyway, error messages will often directly tell us what's wrong with our code. For example, in the Python bubble sort example, we could get this error message below. File main, line 6 in bubble sort, this thing, index error, list index is out of range. That's useful. That's a useful error, right? That tells you directly that you have an off by 1 error. Most of the thing that I complain about with languages like JavaScript and PHP is that they don't provide useful errors like this. As long as we understand what accessed out of range means, that error message is very helpful, right? It means that we're using it, yeah, you know what that means. So we would know to look at our loop counter variable, we'd know how to solve it from the error message. Okay, good. Everybody at this level should be able to solve an off by 1 array error without having to Google the error message, right? But a lot of the time you get rather arcane errors, and it's often the case that like individual programs have their own specific way of giving you an error message. Sometimes they can be quite arcane. PTSD dog meme moment for me there. LaTeX in particular, some of the error messages are very bad. So, you know, it also depends on your level of skill, right? If you're a beginner in a language, you don't have that much experience. Experience in this sense is how many error messages have you received from this compiler in your lifetime, right? How many of these have you processed? That's the only way to get good at it, right? But very often when you're programming, you'll get a lot of weird errors, and there's no shame whatsoever in searching, looking things up, right? Professional programmers encounter errors they don't understand on a daily basis. Why are they still professional programmers? Because they have a means of dealing with that, right? And that is looking it up, right? You are not expected to be an encyclopedia, right? Like, we also kind of have like this problem of the expansion of human knowledge, which is kind of a philosophical problem, right? Like, think about like your 17th century polymaths, right? Back in like the medieval or the early modern era, it was possible for a single person to have a good handle on the current state of the art in most sciences, right? And these people were called polymaths. Somewhere around the Renaissance, this became, you know, no longer really possible. There are a couple of people in the sort of 19th century that are like, come somewhat close to that old ideal, but don't quite make it. And then like in the 20th century, it's like, good luck, you know. The specificity of domains of knowledge have increased over the course of human history to the point where it's no longer feasible for a human being to know everything there is to know, right? This should be fairly obvious, but it is actually an intellectual development that has been tracking through, you know, human history. The same thing has been happening to programming, right? Like, in the 70s, it would have been possible to know pretty much everything there is to know about Fortran, right? But how many languages do we now have to use, for example, in modern web development, right? HTML, CSS, JavaScript, maybe TypeScript layered on top of JavaScript. Server-side languages, you might have to know PHP, Node.js, Django, you know. You might be expected to know 2 or 3 of those, depending on whom you've worked for, who you expect to work for. You know, in addition, there are like client-side, you know, libraries and frameworks that you may have to use on top of all of that, and it's just like, it's a lot. It's a lot of information, and it's just, you know, you just need a mechanism for looking stuff up. So, boom, there's no shame in it, right? Does anybody know what RTFM stands for?
Yeah.
Read the effing manual.
Yeah.
Yeah.
So, yes, read the effing manual. This is kind of like, the slides are kind of portraying this as like the opposite approach to Googling the error, right? There is a tension between these, right? So, before Google searches, developers relied on manuals to debug code. That thick or thicker, multiple volumes. It used to be, when your program returned an error, you didn't get a nice little string, you got a code. You took that code, you looked it up in a table, right? In a printed out manual. That's how development used to be, right? This is a much more time-consuming process, but it did provide you with a much better working knowledge of the software you were using, right? So, this goes beyond programming, but it was particularly popular in programming. Linux still exhibits this attitude to an extent, right? The attitude in Linux is like, you know, it's easy to shoot yourself in the foot, so read the manual, right? Yes, 25 years ago, if you asked a question about Linux on an internet forum that could be found in a manual, you would be told to read the manual. The mentality was that you should do the work to understand as others had done, and not just ask for shortcuts. Over time, the industry went in a different direction, you know. The problem with read the manual is that it's hard. Have you ever seen a man page? I think a lot of you have seen a man page at this point, right? They're hard. As XKCD once put, life is too short for man pages, but occasionally too short without them. Each substantial library might have hundreds of unique error messages, and a program may be made up of hundreds of libraries, and the language itself may have thousands of possible exceptions and error messages. It's just not realistic for a programmer to know all of this. Plus, the attitude is just a little bit toxic, right? Like, we should be trying to reach out to newcomers, to welcome them into the fold, right? Linux in particular has kind of increased in user friendliness as this attitude has been shoved off to the side, right? Well, maybe it would be useful to see how many Windows users we could capture, right? Websites like Stack Overflow emerged, where programmers could post questions and other programmers could post answers. Programmers answering questions are incentivized to build public reputation by answering questions. Quick little like job search, like if you want to be headhunted, which is a desirable state, that is to say, if you want recruiters to go after you rather than you applying to positions, having like good stats on Stack Overflow, I have heard that this is a fantastic way to get a position, right? It's like perhaps even more powerful than a good GitHub, a good assemblage of GitHub projects, right? Because like in order to like produce a good answer on Stack Overflow, you have to really know your stuff. Once or twice I've tried answering questions on Stack Overflow just for fun to see how it went, and it went badly.
It sounds like a good story.
I mean, it was kind of something trivial. I kind of like, oddly enough, I would consider LaTeX to be one of my like domains of expertise, because it's like, of all the things I use, it's probably the thing I use the most, because I use it for all my document generation, right? And it's like, there was a question, I was like signed up to Stack Overflow, and it's like, oh, here's a question on like spacing in LaTeX. Yeah, here's a couple of things you can do in LaTeX for spacing. And it's like immediately, like within minutes, it's like, no, you shouldn't do that. You know, that's stupid, that breaks this, that, and the other. This is the way that you should do it properly. Don't ever do that, right? They were mean to me. But like, that's okay, because I also didn't know my stuff as well as I thought I did. It's probably like, if your ego can take it, you probably like answering questions on Stack Overflow is a great way to get very good at something very quickly. But the whole question is, do you have time and can your ego take it? Yes. Oftentimes, Google is simply a passover to Stack Overflow. Occasionally Reddit. Reddit is more hit and miss, but occasionally Reddit. Question from a novice developer: how often do you guys use Google? Answer: it's like, how often do you guys breathe? As a web developer, how often do you use Google to solve a problem? Again, every single day, every single hour, usually anyway. Yeah, like professional developers have mastered the art of Googling. And I guess this is like, it's like maybe this is like somewhat transferred to the chatbot, but like I think it would be very interesting to see like a breakdown of like actual professionals. How many of them are now using the chatbot for this type of thing? How many people are still using Google? Like Google's opinion, it certainly is that the chatbot should be doing all of this, because like the friggin' answer you get now is the chat generated answer at the top, right? But, you know, when you're looking at at like an answer on Stack Overflow, that is a specific answer to a specific question worded specifically, right? At best, the chatbot is finding a bunch of those and like smudging them together and putting them through a text processor and giving it back to you, right? Like, does that increase the accuracy of the answer? Maybe, possibly. I find it's like reasonably reliable for like latex stuff, you know? Like, I actually find this to be like one of the good uses of the AI is like stuff that you would generally do on Stack Overflow. You can usually get a pretty good answer, but you still have to watch your P's and Q's in a way that, like normally Stack Overflow you can trust without, you know, it's most, like the question on Stack Overflow is mostly like, does this situation apply to me, rather than, you know, is this information false? You had a comment?
Yeah, well, sometimes when you do the Google search thing, it tells you this is what people are saying about it.
Mm-hmm.
Yeah, it doesn't give you a definite answer. It just tells you the links, what people are saying on that particular link or something like that. It just packs it up with you.
Mm-hmm.
Yeah.
Yes, and you know, basically at that point it's the art of, you know, checking a couple of links, seeing what people are actually saying, seeing what the quality of the information is, you know, and, you know, basically the whole question is, the chatbot is certainly less work, but is it sufficiently replicating that process? Is it producing more reliable information on average than doing that process yourself? And like, the other question is like, if it's producing less accurate information, like, are we okay with less accuracy, right? I mean, I don't think it's a coincidence that like, in the last 2 months, how many cloud services have been down for major outages? And how many of those like are using AI now to generate code for their stuff, you know? Like, if you haven't noticed, software's been getting worse in the last couple of years, right? Like, you're hearing a lot more about like, you know, like really stupid friggin' F-ups that like no one would, like, that's not, standards were higher in the past, you know? Like, my typical go-to example of this is this, I think it's called Teacup or Tea Party, but it was basically like a reverse social media site where like you make profiles about other people. Sounds like a great idea, right? And like, they made this app, and it was after AI came out, and I am dead certain that they probably cobbled most of it together with AI, because like if you're on a social media site, like, and that's like the social media, this site required you to do a thing that like sometimes sites require you to do, which is like provide an image which is like your face to like do image recognition to verify something, you know, and it's like your actual face is probably private information if it's, you know, you shouldn't be forced to use your actual face as an avatar, right? Well, they were storing everybody's faces like in just like a publicly accessible directory on their server, right? All you had to do was like, you know, ping that folder and you got a list of everybody's faces. And it's like, that violates security so hard, only AI could have come up with that, right? Like, nobody who knew what they were doing would have done that, right? Which is why, like, you have this effect where somebody can know just enough server-side code to be dangerous, right? It's one of the reasons that I'm so hard on people in the server-side courses, because it's like, you can absolutely know just enough to be really, really dangerous, you know? But anyway. So over time, the industry has not only come to embrace the technology of Googling the error message, but to actively understand how better to do it. You can look at YouTube videos on how to improve your Googling technique. Learning the ins and outs of Google is a great idea as a software developer. Perhaps this has been superseded by the chatbot, perhaps not. Things don't get simpler in life, they only get more complicated until civilization collapses. So, it's not that chatbots are going to supersede search engines, they're just going to be another thing that you have to know how to use, right? So, the most important thing you can do when Googling is to not have the stuff that's specific to your program in there. Like, whatever your variable names or function names or class names are, try to leave that out, right? It works best if you just, like usually it doesn't care about line numbers. You can do reasonably well with it and not take out the line numbers, but like, you should be Googling like your compiler output most of the time. Taking your source code and like throwing it in to Google probably isn't going to work. Although people do have some degree of success with that with the chatbot. When Google searching an error message, you don't want to include these parts because other people asking the same question won't have the same identifiers as you. What they will have is the same error message, error code, number, exception type, etc. These are the parts you want to pull out and search for online. So yes, sometimes you want to add something like the site you want to search on to the Google search. I mean, why wouldn't you just go to the site and use their inbuilt search at that point, right? Don't use Reddit, use Stack Overflow. Often these results would be buried underneath Stack Overflow results otherwise. Oh, so in this example, like if you want it from Reddit, say you want it from Reddit, but Stack Overflow is better, so. You can also use double quotes to keep words together as a joint search term. This forces the Google search engine to tokenize things as like a collection of words that can't be broken apart, rather than, otherwise it's going to break apart each of the individual words and search based on those. It's very easy in Google to like overrun the search engine by doing this, right? If, for example, I write a sentence which may, in fact, horse feathers never have been written indubiously by another fancy neat computer. There you go. It's like, oh, it's not even respecting my quotes. You're not respecting my quotes. Oh, no, it did. Okay, there you go. No results found. But here's some stuff that might be without the quotes, right? Yeah, okay. Hey, it didn't give me any AI for that. Nice. So yeah, I'm sure everybody's done this. Skip. Yes. You can also ask a chatbot couple of warning messages. Best practices are being actively discovered, right? We don't yet know how to use the bloody things. We know more today than we did a year ago, but still very strange and new. Chatbots can give you incorrect and completely made up information very confidently, right? So you are not released from the obligation of thinking, all right? because they're trained on the content of the internet, including Stack Overflow, they're often really good. I would add, and old and outdated, right? The question is, the article on PHP programming that it ingested probably dates from the era when people actually did PHP programming, which is to say probably 10 or 15 years ago, right? So the answers it gives you on PHP programming are probably 10 or 15 years old, right? Which means they are not the embodiment of current security practice, for example. You can give it code and say, what's wrong with this code? And it will say, here is the corrected version of the code. So this is, okay, this is what it's done. It's gone out and it's found someone else's version of bubble sort and it's given you that, right? Maybe it's renamed the variables to what you named your variables, maybe. I am kind of strongly not impressed when all we're using the chatbot for is looking up solutions to very well-known problems, like frigging implementations of bubble sort of all things. Show me a unique problem. Show me a problem that's never been solved before. So, notice that we imagined there was a particular problem. The chatbot told us there was a different problem, and then also fixed the problem we thought was the problem. Again, because it went and found somebody else's implementation of bubble sort and gave us that. Takeaway, ChatGPT, GitHub Copilot, Claude, and DeepSeek, and all the rest of them are they are, according to Kevin, invaluable. But again, they are tools in the toolbox. They are not the end-all and the be-all, right? And in order to be employed, you're going to have to be able to do something they can't. So keep that in mind. So, while read the manual can go to a mentally toxic place, there is a point, right? As developers, we should understand the code that we put our names on as authors. Let's conduct a little bit of a thought experiment, all right? Let's say that you are a developer. Your boss asks you to write a program. You get chat to write a program, and you submit that, and you say, I did this. Let's say that, I don't know, the piece of code that you use infringes copyright and your company gets sued. Who's liable? That's right, you are, not the chatbot, right? The chatbot isn't a person. You can't sue it. It does not have agency, right? You are a person. You have agency. You have standing in a courtroom as a thing that can be sued, right? So, when you are using code from the bloody chatbot, understand that, but that's what chat gave me, so chat is wrong, not me. That's not going to fly. That's not going to fly with employers, and it doesn't fly with me in the classroom, right? If you put your name on it, it's yours. And you have to make sure that it works. And you're responsible for it. It's kind of similar to the idea of if you're a civil or a structural engineer and someone hands you a bunch of plans, do you take your stamp and you say, yeah, that looks good? Or do you go through it in quite fine detail, verify the calculations, make sure that everything is correct before you put your stamp on it, right? Engineers lose their licenses when they use them without verifying what they've put their stamps on, right? It's pretty rare for an engineer to lose their license over something like that, but some time ago, a couple of decades ago, I think, there was this, you guys remember there was this roof collapse in Elliott Lake of like a shopping mall?
Oh, yeah.
You guys remember that? I think it was snow load that caused the roof to collapse, but like the roof was also like a parking lot. So like, you know, rooftop parking lot, I guess they didn't account for heavy snow load in addition to the cars, so the roof collapses, right? Now, that is something an engineer should have foreseen, right? You have to factor snow load into building calculations in Northern Ontario, right? So, what I heard is that the engineer lost their license over that one. Doesn't help that I think people were killed in that one. Like, the roof collapsed into like a Sears or something. But yeah, you should take the same approach to your code, right? You are responsible for everything your code produces, right? This can happen very easily. Security issues, for example. I don't know how many times this very semester I have marked PHP assignments with chat-suggested security stuff that's not even security at all. Did I do the rant about people calling filter input with 2 arguments here? I think I did.
Yeah.
If you weren't here for that class, I got a bunch of assignment submissions where like, you guys all took PHP, right? You guys remember this stupid thing? Filter input, right? Normally you call this thing with 3 arguments, right? Is it input get or input post, the name of the thing you're looking for, and critically, the filter you wish to apply. I received quite a few submissions which had but 2. But 2, that's right. Was it get or post, and what was the name of it? Now, I can only assume that the chatbot gave them that. I'm being generous when I assume that. Filter has a default value. Filter default. You want to see what it's called? Alias of filter unsafe raw. Filter unsafe raw. This filter does nothing. However, it can strip or encode special characters if used together with filter flag strip and blah 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 blah. This filter does nothing. It's even worse than not filtering at all, right? It's even worse than just directly reading out of the get superglobal, because at least if you're directly reading out of the get superglobal, that's an immediate red flag for an XSS attack. This looks like it might be doing something and isn't. So it's actually worse. It's worse than just reading out a get superglobal. And that's what the chatbot gave us. So, yeah, and let me ask you a question. If you're working on the server side and it's like an SQL injection attack happens, and it's a big one, and when they're doing the diagnostics, they find that it was your code, right? How long do you think you stay in your job? Right? Proportional to how much money you just cost the company. Yes?
What would be the percentage, like in this semester, that you think understand has been done with AI in PHP?
It's, so it's kind of, it's a tricky question because like, I've only so far marked assignments 1 and 2. Assignment 4 will be a good one to determine that because it's a lot, like it's very different from when you guys took it.
Is it the PDO connection?
Yeah, so like judging on the way that people are filtering, I think, despite multiple warnings of course, about half the class was using completely wrong and terrible ways of filtering out XSS attacks. Now that doesn't mean that that doesn't necessarily mean that they were using AI, but and it does also people who weren't in that category weren't necessarily not using AI. They were perhaps just using it more intelligently, right? But like, if you asked me how many assignment submissions I get, which in my personal estimation contain traces of AI usage, I would have to say something like 70 to 80%. And I'm being conservative. Actually, over lunch I was listening to Dr. Gilbert bellyaching about it in, what course was he talking about? I think it was Java. Yeah, it was Java. And he's like saying things like, well, if you're using a Lambda functions, we don't teach Lambda functions, so you're getting it from somewhere, and the somewhere is usually AI right now. He's actually introduced a component of the Java assignments in that course where you have to come into the classroom and explain your code for like 40% of the grade on the assignment. And he's saying this is mostly turning into an attendance test. But yeah, and occasionally more than occasionally, quite frequently, he's taking people's code and kind of throwing it back in their faces and saying, go do the assignment. So, yeah, it's ubiquitous. It's ubiquitous. But, I would say that,
Yeah, I don't remember using Lambda functions in Java.
yeah, no, they're not in,
Because they're more like,
C#.
yeah, C#, yeah. But in
Mhm.
Java, you're basically learning polymorphism
Yeah.
and drawing the grids and all that stuff.
yeah, and like Java itself, I think is in need of it's in need of an update. Like, pretty much every course always needs to be updated, but like Java, I think has been like a bit too stable, basically the whole issue of AI hasn't really been addressed in Java, and Dr. Gilbert's trying, but the testing structure also needs to be adjusted so that you have to pass the tests or else. He convinced me fairly of it that like did you guys take Java with me? Some of you guys? No? JavaScript, right? Some of you, if you know me? No? Oh, okay. Server side?
Yeah.
Yeah. So with so in Java they've got the redemption arc, right? You can get like the exam can be worth 70% if you score sufficiently well on it. That blows out the 2 midterms, and Gilbert thinks that this is a policy that needs to go, because basically like you have all these people who cheat their way through the assignments and then come into the exam, in the hopes that like they will be able to like it looks like a minimal path to completion, right? And basically some things that we need to do is start addressing minimal paths to completion of courses. Like for example in this course, there's absolutely no reason why we should be doing videos when you could do in-class assessments, right? it was designed under COVID, but like if I had the room full of people and everybody had to like put their hand up and show me when they like created the issue on GitHub, and I was walking around with a little clipboard and checklist, I could do that. That's easy. That's like in-class assessment. You actually have to be here. Like, it's kind of hard to get AI to fake like creating an issue on GitHub, right? And it's, it's sufficiently obvious when people are using terrible techniques on like Bash. And like the other advantage of that is like when I see 2 or 3 people doing stupid things like doing global delete operations on a file using sed patterns in VI, right? I get up at the front of the class and I'm like, don't do this because it's awful, here's the reason. And then hopefully people stop doing that, But we just, we've got some things to tighten up. But I'm hoping that when I actually finally get the time to rewrite client server side, I might be rewriting client and server side this summer. But I'll see if I can't address some of these issues. But like my general philosophy is kind of coming around to like AI on assignments. Use it if you want, but just remember there's a test, right? And the test is going to be the test, and you got to pass the test. So it's like there's really no proactive way of solving the problem, like aside from, you could have everybody do things in class, that way in theory you're monitoring it, but then you have to have people writing assignments under the same conditions they write tests. This is not sustainable. This, by the way, is an approach that Steve Adams tried to take with programming fundamentals. Just not sustainable. Not to mention, like, testing practice itself needs to be under a tighter lock and key, because, like, it's very inconsistent across sections. So, like I can pretty much, final exams, because everybody's kind of collected together, I can kind of like muscle my way into having decent testing practice in most rooms. But, leaving it to individual professors from the individual midterms is often like dubious. And I can see people nodding in the crowd. You guys know exactly what I'm talking about. But, with respect to like, more in-class evaluations, sure, but then you need the time for it, right? Some of the courses are structured in a way that you can do that. This one, you could argue, if I spent less time doing this in like the opening weeks, we would be able to have done that through the semester. But, yeah, like Java's at 5 hours a week. In theory, you might be able to squeeze stuff in there. And like, it kind of like, the problem is what you end up pushing to the margins, the thing you end up pushing out of the classroom is the practice. And people don't do anything out when they're not in the classroom, right? Aside from assignments. So it's like, it's like, what do you gain, what do you lose? What are you willing to sacrifice? It's a difficult problem. But like for me, fundamentally, like program quality itself rides on tests and particularly final exams. And there's no way around that. That's actually, believe it or not, that's like the consensus which educators are coming to, is the return of the test. For a period of time, we thought that tests were mean, but then we realized that tests are the only scalable solution to, seeing if people's knowledge is up to snuff. So, assignments are useless now, and it's unfortunate because it's, still the best way to learn is to do the assignments, right? The assignments are the learning, right? This is the instruction, the assignments are the learning. with, you know, assignments devalued, people will do less learning and more testing. It also, like, testing kind of encourages, like, bad cultural habits, like cramming for tests, right, which is, like, less ideal, but, like, again, there's no options. As far as I'm concerned, there's no options. Testing is the only thing we have left. So, aside maybe from in-class evaluation, but again, you have to restructure the course in a very fundamental way to support in-class evaluation, and it means that it pushes more of the actual instruction and learning outside the classroom, which people won't do. So, you know, it's like, how do you maintain high-quality education in you know, against the rising tide, right? Basically, the way that you do it is like Prometheus. You get yourself strapped to a rock, and that rock says, "We will have a final exam," and then you allow the students to peck your liver out every night, and that's how you do it. Okay. Kevin feels that this response gives a good balance between Googling the answer and read the manual. How often do you Google? Almost daily, if not sometimes multiple times daily. As others have stated, it's oftentimes much quicker to Google than it is to hit the docs. The difference comes in whether you understand what you're doing or are simply copy-pasting code and hoping it works. Yeah, if you're copying, pasting code and hoping it works, it's like, you know, basically you're incurring technical debt when you're doing that, right? Goodness me. I promise the other two presentations are shorter than that. The other two slides are shorter than this. I think we're over halfway through. But shall we have the break? It's about 5:20. Yeah? Cool. All right. I hereby forthwith declare a half-hour break. Please be ready to resume class at 5:47. Thank you very much. All right. Let's keep going. Debuggers. Debuggers are tools used to debug programs. Next slide. No. So, essentially, print statements are good, but they're a lot of manual manipulation. The purpose of a debugger is to try to give you the same information that you could get by using print statements in a more convenient way. Now, debuggers, if you know how to use them and can use them effectively, have a similar level of effectiveness at print statements, and you can use them more quickly and more easily. However, it is a skill, and it takes a certain domain of knowledge to use them, so, you know. Precise feature sets in debuggers will vary, but there's a sort of solid core of expected features that you would expect to find in any debugger. Different environments and IDEs will include different debuggers with different capabilities. When you're doing low-level systems programming, a debugger might allow you to see what memory is set to or what CPU registers are storing what, right? Typically, the most core functionality of a debugger is that it allows you to step through a program's execution step by step. The debugger can be made to pause execution at breakpoints that the programmer specifies. Breakpoint is an important term. The debugger can output the values variables are set to, allowing us to trace execution. So, have you guys ever seen Python Tutor?
No.
Alright, it's a website. I often show it to people during like intro course type things. Python tutor.com. Yes. Not just Python, it also does Java, C, C++, and JavaScript. So let's consider Python, just because it's easy. Don't worry about the AI stupidness. Just, here you go. So let's say that you have something that's like, kind of like memory pointery in Python, which it's actually surprisingly easy to do. Let's say you have a list, right? 1, 2, 3, 4. Let's say you copy that list. L at 4, or L at 2 is equal to 10. Visualize execution. So, you can see it shows you where you are in the program, and it actually gives you a timeline where you can step through the program's execution. So we've now initialized the program, and we have the L variable with the list object declared. This one's also very, very good for understanding how functions work, because this is your actual system call. This is like your call stack, right? So I'm assigning M to L. What does that mean in Python? Well, it doesn't mean duplicating the array, right? And this is like very important if you're understanding Python programming. I'm not sure to what degree you get into this type of depth in intro programming. I've sometimes been quoted as saying that anybody who takes intro programming and then claims to know Python on their resume is essentially lying. But, you know, so it goes. You can see that what this thing is actually doing is duplicating a reference to the same data structure. So if I modify value 2, the third value to 10, you can see that change shows up in both data structures, right? If I go back, like the thing that this explains, right, is if you ask for M at 2, it's like a point at which you can have unexpected functionality, right? People might not necessarily, people are sometimes surprised that this is the 10 that was assigned here, because the whole point of this is called aliasing, right? But you can see how like that shows very nicely in a clear and visual way how things work, right? You can also, I'll just show you quickly how it works for functions, because that's kind of interesting. Let's say we want to write very quickly like a recursive summing function, right? You guys have done data structures and algorithms mostly. You guys know what recursion means, right? Yeah, awesome. Def recursive sum, taking a value x, return x, x at 0 plus recursive sum of x from, I think it's 1 to the end of the list. Python list slicing syntax. And I'll be able to see if I did it correctly. Of course, you have to actually call it recursive print recursive sum of L. So you can see at the end of the program what's going on. Ooh, index is out of range. Ooh, that's right. So you can see I got a problem. If length of x is greater than 0, or is greater than 1, do this. Otherwise, return.
Put curly braces.
Oh, bloody. Thank you. Return x at 0. I forgot my base case. It's been a while since I programmed recursively. There we go. Yeah. There we go. So, executed without error. We can see the program now has 22 steps. The limitation of this tool is like, it'll only crunch programs up to a certain size, right? But it's very, very useful in so far as it goes, right? So, next, we're initializing L. We set m equal to L, all that stuff. Now, defining the function recursive sum. Recursive sum is a function, right? Now, we print recursive sum, which means we start a new execution of recursive sum with x pointing to this very variable, which tells you interesting information about how Python works. That is also an alias. Modifications that you make to the array from inside of this function will happen everywhere else too, right? But you wouldn't easily have known that if it hadn't been for these nice arrows, right? So, we go into the function, we have an if statement, we execute it, we then go to this line. Next, we call recursive sum on this guy, so you can see it's now calling on that segment of the array, but this also tells us something interesting about list slicing and syntax. List slicing syntax creates a new copy, right? So we're now recursing over this copy. We do that again. There we go. There we go. Now, because the length of the list is 1, we jump to just returning x of 0. Return value is 4. That is passed up the chain. Return value is 14. Return value 16. 17. And that's printed. So you can actually see how the data flows. It's very, very useful, right? Again, only up to a certain level of complexity with this tool, but honestly, I prefer this thing to most other forms of debugging, because like, normally you have to like manually set where the breakpoint is, but this gives you like this very nice timeline slider, where basically every line of code is its own breakpoint. You know? Make sense? But yeah, so debuggers, that's my favorite. That's my favorite debugger. Yes. VS Code comes with built-in debugging, a debugger capable of debugging JavaScript code using Chrome. Various extensions allow it to act as a debugger in a wider range of scenarios. Like a very, very typical VS Code extension is debugger for language X, right? To use the debugger, first create some breakpoints by clicking to the left of the line number of the desired breakpoint. So basically, so a breakpoint is like, sometimes it's a little red circle, sometimes it's the little stop sign, right? You say, execute until you hit this line. That's what a breakpoint is. We then stop execution, and we can look at the contents of variables. We, of course, have to start debugging when we're intending to debug. You can then see the status of variables and step through execution using the controls in the pop-up window. Incidentally, when I rewrite server-side from Node, have you guys heard of Chrome Developer Tools? Man, I forgot how to get there. I go Developer Tools. It's like where's the? I think you just have to like. Okay. More tools somewhere. Print.
Is it different than
There it
just
is.
using F12?
Yes, it's different from, well, yes, there's a different thing than the inspector pane.
Okay.
Yeah, although, yeah, like, within the context of web, of course, this thing is like essential, right? Yeah, no, there's like in when you're doing Node, you can like set up a special browser session that like connects to the Node process. You have to like enable like debug tunneling on the Node process, and like it'll report all kinds of debugging information to like the Chrome developer thing, like what line are you on? You can do breakpoints in a GUI on the server, right? Node actually has a really good command line interface as well, which you can do quite a lot of debug stuff if you want to do it in terminal. Like you can set breakpoints like manually by like leaving particular types of comments in the file, and then you can like run the debug process as a CLI process, because of course that's useful because we're talking about servers, which are a lot of the time in Docker containers now. They don't have GUIs, but like Chrome Developer Tools allows you to tunnel to the server and display a lot of that information in a GUI anyways. So yeah, it's good, it's cool. I guess my point is there are lots of different types of debugging tools. Okay, if the instructor is saying I had to do a bit of fiddling to get this work, imagine how much fiddling you're going to have to do. A whole symphony of fiddling, that's how much. A whole fiddling quartet. Clicking on OK or the equivalent value on various pop-ups that VS Code came up with. You may need to play around with it a bit as well to get it to work. As far as I'm concerned, every course should cover a debugger and how it works. There are many more debugging techniques and tools available, though we've covered some of the major ones. We can pragmatically use and combine these tools and techniques in our toolbox as the situation calls for them. Any questions about debugging? All right, everybody sufficiently debugged? All right, let's bug out. We still have work to do. Bug out is Army slang for breaking camp quickly because the enemy is coming. Test-driven development. I'm going to test everybody's patience with this one. Yeah. All right. So the concept here is fairly simple. Does what it says on the box. Test-driven development is a software development process wherein you write the test cases for the software before the software is fully developed. Most of us test in post, right? Test-driven development asks us to write the test cases before we finish the code, right? Basically, this is an approach that is used in CI/CD pipelines, right? This is most amenable to automated testing. So the normal sort of way that you develop something is you write the code and then you test it. Here, you write a little code to get yourself started, then you write tests, then you write more code, make sure the tests are still valid, right? It's amenable to continuous integration. So, progress at meeting requirements as we implement can be monitored and verified. So basically, if you have a bunch of tests already set up, you can tell if your new branch breaks them, right? So, test-driven development. 1, we write the test. 2, the test fails. 3, we write code. 4, the test passes. 5, we refactor. Then we write the test. So, first, we create a test that should pass when the requirements for a feature are satisfied. This is actually a fairly good way of specifying what the feature is even supposed to do, right? This is a thing, again, like a lot of these programming techniques come down to think the problem through before you start coding. This is a way of thinking the problem through before you start coding, all right? Next, we run all tests. We expect the new test to fail. The objective is to validate that the test will run and not pass automatically. So if you've written a test for a new feature that requires that new feature, and it runs without that feature being added, then it's probably a bad test. It doesn't actually test the feature. Everybody who went through software testing probably knows that the writing of tests is a non-trivial function, right? Write the simplest code that you can to pass the new test, right? Check that the test passes, and then refactor the code, verifying the test as you go along, right? So, you write tests to test a feature that doesn't exist. You then do your shortest path to those tests passing. Then, you fill in the details, right? Is this making sense? We repeat the TDD steps for each new functionality and related requirements. You can imagine why this is popular in CI/CD. If these tests are automated, and if a commit means you have to pass the tests in order to push something, right? Then this process is being encoded in the sort of code repository management system, right? The idea of TDD is closely associated with the XUnit frameworks and agile development methodologies, I would say DevOps as well. The creator of the SUnit testing framework, Kent Beck, that spawned the XUnit family of testing frameworks, helped to popularize TDD as a technique. Kent rediscovered the technique from an old book when computer programs were represented on tape. Kent is one of the signatories of the Agile Manifesto. So, there you go. Test-driven development forces developers to focus on implementing requirements correctly as a first step. Writing tests can force us to understand the requirements. Utilizing our understandings of the requirements has us confront misunderstandings. You know that thing I was saying where you need to understand the problem? Yeah. In traditional development, we more passively read the requirements than implement them. But did we truly understand them? How do we know that we truly understood them? You have been given a requirements document. It's like, oh yeah, I read the requirements, and then I did my own thing. But if something's actually checking to make sure that you implemented the requirements, then that's better. Writing tests first ensures that all requirements are actually tested. Otherwise, we could skip tests when things get busy, which is like, can I give you a little hint about adult life? There is no period of non-busyness, all right? You are always busy with something, all right? There is never enough time for, maybe this is just my experience because I've got 3 of the little ones at home, but like, there is never any time for anything. If something can get cut from your schedule, it is cut from your schedule, all right? That is how adult life works, all right? And I'm not resentful at all that I can't play as many video games as I used to. The third step regarding our non-optimal code first aligns with software principles. For example, if you start by implementing like the absolute bare bones of this must pass the test case, then you have actually conformed to you aren't going to need it, right? You're kind of thinking more in terms of like incremental necessary improvements rather than like software as a monolith, right? Yes, the idea is not to implement more than necessary or with more complexity than necessary, with the thought that future implementations will benefit. Note from our favorite instructor, Kevin Brown, TDD aside, this is exactly how I have written code for the last 15 or 20 years now, and he's personally a strong believer. Yeah, to that I would say, Kevin, my thesis started out that way too. That doesn't mean that software can't go wrong, right? Sometimes a fully realized system is necessary to test a requirement, and TDD may not be able to handle this. For example, like there are some chunks that come in big chunks, right? Like if you gotta connect to a database, there's no real like incremental step to get connected to a database. You just gotta connect to the database, right? It can also be a hard sell. Unit tests can be hard to justify to some managers, and TDD involves writing tests before code that implements clients' needs. And this is perhaps even a harder sell. It's, time to market. Time to market is the problem, right? So let's imagine that we have 2 hypothetical video game consoles, right? Let's say that both of them realize that the next generation of consoles is going to be necessary at about the same time. Let's say at the same time, right? Let's say some new technology comes out and they're like, that's gonna, we gotta do that. We gotta have a console that uses that. Maybe it's 64-bit processors or something, right? If you have console A on the market 3 months before console B, console A has made 3 months more sales by the time console B comes out. By the time console B comes out, you already have a significant number of people who've already invested financially in system A versus system B. They are going to be buying the games for system A, not the games for system B. So, time to market is a fight you want to win. And the more you win it by, the better. This is the managerial perspective, right? So anything that delays time to market is bad. and testing things before you even have anything to test, that might be hard to sell to a manager who is, highly interested in time to market. It's all going to depend on the type of business that you're in, right? Some markets are much stronger in this respect than others, right? Electronics is a very strong time to market business, right? Other things less so. But the whole thing is you will always have competitors, right? TDD increases maintenance, so now all tests must be maintained along with the code. So it also increases the amount of work it is to develop, right? Because you now are maintaining a set of tests as well as the code itself. That wasn't too painful, was it? All right. And now we have PyUnit, a unit testing framework for a language most of you only barely have a passing familiarity with. Whee! So, Python is a good language to properly learn. I think it was 3rd place on Stack Overflow. PyUnit is a Python unit testing framework which supports automated unit testing in Python. It's modeled after JUnit, a similar historically important framework for automated unit testing in Java. Both PyUnit and JUnit are part of the XUnit family of testing frameworks that follow similar conventions. So, pick your language, see if it has a unit testing framework that's similar. One oddity of PyUnit is that names are camel-cased instead of snake-cased, which is the Python standard, but this is because the rest of the XUnit family does it. PyUnit is built into Python 3, so you don't need to use pip to install the package. You guys know what pip is? What's pip?
Python's package manager.
Yes. Python's package manager is called pip. Do you know why it's called pip? No? Okay. Notably, there are other popular unit testing frameworks for Python. So to use PyUnit, we import the unit test module. Import unit test. Test case class definition. But of course, you guys didn't really do class definitions in Python. So, so this is how it maps to Java then. This is your class declaration line. This here is your, what's it called? Not importing, inheriting. This is your inheritance, right? In braces here. Interestingly, in Python, you can inherit from multiple other classes, which is gross in Java, and you don't do that in Java, but in Python you can. So, these are methods, right? You're just defining a function inside of a class, that makes it a method. The first argument of each of these methods is a self-referential identifier. So Python makes you declare the name for this, the this keyword in Java. Every time you attach something to the class rather than to the local declaration, you have to use self or, you can actually call it this and use it as this if you want. You can change that if you want, but we have these methods, assert equal, assert true, assert false. These are all methods which are defined inside of the test case class. So this is a test to see if the string lowercase foo dot upper yields uppercase foo, which it does, spoilers. Assert true, foo is upper, right? If this expression comes out true, this test passes, right? Same thing for assert false. So basically, and assert raises tests to make sure that when this occur, when this thing is run, the correct type of exception is raised, right? The main crux of the unit test is this concept of assertions. Did they do assertions in the testing class? Maybe?
Yeah, I think so.
Oh, I thought you were raising your hand.
I think so.
You think so? Okay. Surprise, surprise, I'm most familiar with assertions as they exist in C. There's an assert library. Basically, this is what an assertion boils down to, right? It's like a slightly fancy if statement. If the predicate comes out false, it crashes your program. Or it raises an exception or something, right? In C, it just crashes your program. Non-zero exit status. This is what this is doing, but it's giving you a slightly nicer report. So, we create a derived class of unittest.testCase to create a test case class. A test case class, say that 5 times fast, can be made up of individual tests. Each test should be a method which starts with test. We typically use test_test_name for each test. This naming convention informs the test runner which functions to run, so we must follow it. So sometimes, stuff like this is enforced. This is a case where, the test underscore is enforced. We use assert functions to check expected results against actual results, i.e., should the test pass or fail. If an assertion fails, the test fails. So, for example, if we run, as we were given, ran 3 tests in 0 seconds, okay. 0 kills. Did you guys know that that's what OK stands for? That's true. It's also military slang. OK means 0 kills. How are you doing? Nobody died. Which is kind of like the perfect expression of modern usage of the term OK, you know. Anyway, the V option will give us specific information about each test. V for verbose, right? Tells us each of the individual tests that it's running. We can also run specific tests within a test case, again using command line parameters, running one of those instead of all of them. We can define setup and teardown methods, which conduct any setup and teardown work respectively for a test case. The methods will run before and after each test method in the test case class. So one thing to keep in mind about these test cases, they are independent of each other. The program state is reset between them, right? They're independent testing. For example, create an object with the methods to be tested, populate a database with some test data. Teardown work might involve restoring the database to a previous state, disconnecting, deleting files created during the test, etc. So, for example, maybe part of your setup routine is to take a file somewhere, copy it to a temporary directory. The test then uses that file in the temporary directory, gives you your results, and then as teardown, you clear the contents of the temporary directory. Make sense? Good, good, good. Example, setup and teardown methods. This is what class declaration, or object declaration looks like in Python. Fairly similar to how it looks in Java, except no declared type, because of course this is Python, and no new keyword, because that would just make too much sense. There's also a dispose method if you don't want to leave the thing to be collected by the garbage collector. Tests within a test case class, i.e. the methods within a derived class of test case, will run in an order determined by Python, and that is the alphabetical order of the test names. We can define multiple test case classes as part of a test suite, multiple classes in a module of some type test case. Like, for example, we could take this object and make it, the base class for other test case classes, right? Each test case class should be able to run independently of the other test case classes. We can include the test case code in the same module the code is being tested in. But in general, the best practice is to create unit tests in separate modules, and to include the module being tested instead. This separates concerns better, and we don't ship test code with the application code. You don't want to do that. Here are assert methods which are provided by XUnit testing libraries. You can see you have your standard set of Boolean operators. We have a few like test for membership in classes. I believe that's what that is in Python. In is a search operator in Python. Did you guys know that Python has an in operator? Yeah, it's very, very convenient. You can just say, Python interpreter. If I say 5 in 1, 2, 3, 4, 5, that is, yes, thank you, I need to print it, yes, thank you. Not quite an interpreter then, true. 10 in, false. So it's basically just doing a linear search, but it's bound up in an operator, which is kind of convenient. Kind of convenient is like the slogan for Python, I guess. Oh, I'm sorry. Instance is the one testing for class membership. I can't actually remember what is does in Python. Exceptions are actually an important thing to test for as well. We can use assert raises to check if an exception is raised when a function is called. This uses the rarely, there you go. Self.assert raises type error given, more in the thing that you're calling. This would be, I guess that's a function name, and that's like the input that would cause a type error because it's not an integer, it's a string. There's a lot more to PyUnit that we covered, but this is a good foundation. Official documentation here. And that's We didn't quite get to pair programming. I guess let's skim it together since we have a little bit of time. Because it's probably like, oh, it's only 17? Good grief. We actually would have time for a cold read of it. Let's just take a look, see if there's anything interesting in here. Eh?
Yeah, when we upload, we can take that back.
So, pair programming. Technique that involves two programmers working together at the same workstation. So, I don't know, like way back in Java, like if your instructor during Java like did some of the exercises in Java according to how it says you're supposed to do them in the curriculum for that course, there's a couple of ones where it's like try pair programming. Yeah, it's basically one person's at the keyboard typing and the other person's backseat driving, looking over their shoulder. Surprisingly not terrible in terms of effectiveness, right? Why would we do this? Would it slow down progress, speed it up, or improve quality? One of the common methods is to have a driver and navigator split. Driver has control of the keyboard and mouse. Navigator or observer focuses on the overall direction of programming and reviews the code as it's typed. It's actually kind of useful to have someone pointing out when you're making syntax errors. This is when I do code on the board, like much of the time the class is like pair programming with me, which is very effective. Like for example, when I put curly braces in a Python script earlier today, right? That's actually quite useful, right? Because you don't always catch those things when you're writing them, right? But that's kind of the whole idea. So this is lawful good pair programming. Chaotic evil is one programmer gets the keyboard, the other gets the mouse. It's like those multiplayer games that expect two people to hold the two sides of the controller. The idea is the driver is focused on the tactics and the navigator on the strategy. Navigator can anticipate future problems. Driver can use navigator as a safety net. Pair programming can be done in person or remotely. Has anybody it's kind of a difficult analogy in the age of GPS navigation, but if you ever try to drive somewhere by map, right? It's very, very useful to have a co-pilot, right? Because you really shouldn't look at a road map while driving, right? It's bad. It's so comedically bad they use it in comedy movies. It's a bad idea, right? Pair programming can be done in person or remotely. I can't imagine how awful it must be remotely, because the introduction of even a slight amount of video feed lag would be almost completely destructive to this process, right? You need to be able to say, you need a semicolon, right? And the response to that needs to be instantaneous. Don't get too caught up in the idea of defined roles, because communication is critical to effective pair programming. While the driver types, both the driver and the navigator are talking about the problem being solved and how to solve it. Very good. Other styles, ping pong. One developer writes test cases and the other developer writes code to satisfy them, and they switch as they go. Unstructured pair programming is where there are no roles or attempts to define them. Programmers work freely together in an ad hoc way. Seems like that would just evolve quickly into the way you always do things, you know? Is pair programming inefficient? Wouldn't it be faster to have two people programming separately? Yes. Pair programming does result in writing code slower than otherwise. But the inefficiency isn't as bad as you might think. Studies show it's only about a 15% loss of efficiency, not a 50% loss of efficiency. 15, yes. Studies also show that pair programming results in code with 15% fewer defects, which is good. So basically you're trading off efficiency for improved software quality. That's good. This is sort of a classic trade-off. Sometimes you'll want to make that trade-off, sometimes you won't. Often you will, right? Pair programming has other organizational benefits. It improves communication between teammates and improves knowledge sharing, similar to code reviews, but the bus factor is lowered. Senior developers can mentor junior developers. That one might be key right there. Again, it's going to depend on whether your ego can take it, constantly being backseat driven and micromanaged by a senior developer. But if your ego can take it, it's probably a way to very quickly become better at programming if you take seriously the mentorship, right? Programmers generally prefer pair programming, except of course for the most hardened introverts. This is true after programmers try it. Before it, they are skeptical. Programmers reported a lower level of anxiety, knowing that the code is more likely to be free of major defects. You can also share the blame as well as you can share the blame that reduces your anxiety as well, right? There is an idea that introverts lose energy from social interactions, but anecdotally, even if you are an introvert, you may find this does not hold with pair programming. The social interactions are very focused, goal-oriented and supportive, and it makes for a less stressful interaction than a cocktail party. So, basically, and this is kind of an interesting fact about introverts, is it's not that they hate people in general, it's just that they're much more selective about who they let into the inner circle, right? For example, my wife is like a 99th percentile introvert, right? She will go to a family function where it's her family and not say 3 sentences the whole time. And it's with her own immediate family. And it's that's a pretty high level of introversion right there. And yet when it comes to discussing the affairs of the day, you would never know she was an introvert. Speaking to her as her husband, right? So it's all about the circle and who's in the circle, right? So if you're, if the other programmer is in your circle for this activity, maybe it's okay to do that. And cocktail parties are awful. They're terrible. If you can avoid them at all, by all means do. Also, try avoiding going to weddings where you don't know anybody except the bride and groom, or the bride or the groom. Try to avoid those. Those are bloody terrible. Even if the party itself is quite nice, it's you'll not have a fun time. Pair programmers tend to create simpler designs. Keep it simple, stupid. More design alternatives can be considered by 2 programmers instead of 1. Sometimes you need someone to tell you your stupid idea is stupid. Otherwise, you actually go and implement the stupid thing. We can see this in the lines of code produced by individuals versus pairs. So, you can see, in terms of lines of code, for 3 programs, this is not a lot of data. Presumably, this is a link to a study. Individuals produce significantly more code than collaborators, but as we know, just because the program has more lines of code doesn't mean it's more right. Shorter programs are often more correct than longer ones, right? And it's also less surface area for bugs to live on. Watch Watch the Master. This name describes a problem that can occur when a more junior developer is paired with a more senior one. Basically, they aren't really actively participating, but are kind of pushed into an observer mode, right? They may become disengaged and bored, right? I might rename that to Hold My Beer. So the if this is happening, then the person who's becoming disconnected needs to be switched into the having the keyboard, right? Some people say that pair programming should be roughly equal. Pair programmers should be roughly equal in skill for this reason. Others disagree, citing the junior-senior pairings, mentorship, etc. Juniors can also challenge the conventional wisdom and standard practices of senior developers. It's the always famous, but what if we re-implemented it in Rust, right? Junior-junior pairings aren't generally recommended. Which is why, like, when I teach, like, you know how I said that's in Java? I did that for a couple of offerings of Java, and then I was like, nah, this is stupid. Because, like, there's a line in the Bible, right? When the blind lead the blind, they just end up both falling into a pit. And that's generally what I was observing from pair programming among, people in the Java class. Social challenges. While many programmers prefer pair programming once they've tried it, some do not. Some people are awful and awful people to work with. Sometimes it's not their fault that they're awful people, but sometimes it is their fault that they're awful people. Sometimes people simply prefer to work individually, and forcing them to work with others may lower their satisfaction and work ethic, not only of them, but of everybody in their immediate vicinity. Some people just don't get along well enough to work together effectively. Personalities are different, etc. Logistics. How long can two people really work side by side together for? Lunch breaks, bathroom breaks, meeting times, etc. The practice is likely limited to time blocks with breaks built in. Best practices. Switch roles frequently. Communicate consistently. And take breaks often. Take breaks often is actually like, I'm kind of like torn on that one actually. It really depends on like how well you can knuckle under, If you're having difficulty getting through a task, then I think taking breaks is a good idea. But if you're like in the zone, by all means just stay in the zone. Many of you are still fairly young, all right? When you're in the zone, treat it as sacred. Because the older you get, the less you'll be in the zone. I think it's like, as you age, you just lose that ability slowly by increments, the ability to be in the zone. So treasure it while you're young, basically. Honestly, being in the zone can become an aspirational state, It's like, man, if I could only get 3 hours to myself and just to program, put my music on, put a little bit of Lo-Fi Girl on, get into my keyboard, and I'm just coding. I would love that. But of course, email, children, stuff, and bother, and students, always students. It's always something to do with students. This job would be perfect if it weren't for the students. But yeah, no, it's, if you're the type of person who gets in the zone and you can be very highly productive when you're in the zone, protect the zone, right? Like 3 hours in the zone and you might accomplish like what you might otherwise have taken like 3 days to do. So, you know, don't take a break just to take a break. Only take a break if you need a break. Alright? Alright. But of course, like, you know, oh man, it's so awful when like you're in the zone, but you have to pee, you know? It's the worst thing ever. Best practices, show respect and empathy. I mean, that should be fairly obvious on the surface of it. There are codes of conduct at developer conferences that ban this sort of, let's see, let's actually read, this might be funny. If the developer you are working with does not know something, even if you are surprised, you should not express this surprise. Okay. There are codes of conduct at developer conferences that ban this sort of surprise reaction. I guess it's like, ooh, okay, this is the difference, right? You know how like earlier on I was like, ooh, did you guys know about like the in operator in Python? And I was like, oh yeah, it's cool, here, I'll show you. You know? But if I had said it like, you don't know about the in operator in Python. You don't know about it. Are you even programmers? It's very condescending, right? Don't be condescending, right? It can be done in a passive-aggressive way, which is called intellectual violence. Intellectual? By whom? When someone uses knowledge to intimidate or shame others. I mean, okay. Though it can, I didn't read this ahead of time, so. Though it can be done out of sheer unawareness for how it may make other people feel. Yeah, that's part of the problem with programmers is like, you know, not all of us are, like some of us are in programming because we don't really like get on with society, you know. As a practical matter, there are so many more important things to know, and nobody knows all of them, so an experienced developer should never be surprised if somebody lacks knowledge they consider to be core or important. Just remember, all of you, everything you know, everything you think you know, will at some point be wrong. Okay? Adopt a growth mindset. This is like advice on not being a huge egoist at this point. A growth mindset is when we understand our own knowledge and skills can grow. What we know is not fixed. It expands over time and hopefully does not contract over time. We should approach pair programming as a chance to learn and grow. Unless the person you're with is a complete and total dumbass. Sometimes you just can't learn something from somebody, right? Reflect. At some interval, daily, weekly, monthly, we should reflect on the effectiveness of our pair program. What is working? What could be improved? Take time out of your day every day to meditate, you know. Mindfulness exercises. Everybody has time for that, right? Don't forget the documentation. Documentation is also part of programming. Plan and set goals. Yes, I will refer once again to the extremely useful and valuable checklist of things. Checklists are extremely useful. While a simple, remember that this was made under the pandemic settings, okay? While a simple Zoom meeting with a shared screen can be enough to perform pair programming, specialized tools do exist. Live sharing is a plugin for Visual Studio Code that allows developers to work on the same project in real time. Wow, that sounds like giving people a thing to use for academic integrity violations, doesn't it? Mob programming is an extension of pair programming. Now we're talking about how, people, anyway. Where an entire team works together at once. Still, at any one point, one developer is doing the typing. Now the entire team is discussing. This sounds like hell.
Yeah, it is.
That sounds awful. It's like, rather than having one guy backseat drive you, it's like, literally you have a swarm of them. Oh man, I saw a meme once, which is like a Roman illustration of somebody getting beaten with sticks. That seems like that would be. All right, and that's actually the actual last slide. Okay! We even got through the stuff I didn't think we'd be able to cover. Any parting advice? Just don't worry. Everything will work out in the end. When a door closes, a window opens. The path through life is not linear, right? Everything has its swings and roundabouts. And just be yourselves, It's too much mental effort to try to be anybody else. So, yeah. And, learn Node and React. And learn containerization is going to be very useful in the future. Don't over-rely on the AI because it is, you are understanding the AI correctly if you think of it as a dagger aimed at your heart. All right? The dagger might be useful, but it is always aimed straight at your chest. All right? You can still cut open your package of cheese on a dagger that's aimed at your heart, but it's still a dagger aimed at your heart. All right? That's it. Have a good life. It's very flattering.